So the three methods. The first one is the computation method. The computation method is very similar to the examples that we have just done. In this method, we begin with calculating the total weight of everything. So we add the weight of the airplane, pilot, passenger, cargo, fuel, etc. Everything. And then when we calculate the total weight, we check that with the maximum ramp and takeoff weight. You can calculate the weight using the maximum fuel at first and then subtract the fuel to bring the weight within the limits. Or you can calculate the fuel required using the navlog and then use that for calculation. Any which way, you have to ensure that the maximum weight is not exceeded. You can use a printed weight and balance worksheet like that, or just a simple format using your pen and paper. After calculating the total weight and bringing it within limits, you can use the arms from the POH and get the total moments. Important to note here is that the figure that you get in the POH gives you all the arms. Sometimes the arms of the seats are variable because the seats are adjustable and they can move forward and aft. So please take a note and consider this as well. After adding the moments together, you divide the total moment by the total weight and you get the center of gravity. This is the position of the center of gravity from the reference datum. See, the total moment of the whole system is equal to the moment of the CG because we added each moment of each thing in the airplane, and that is how we arrived at our CG. This is the same concept. Once you get the CG, now all you have to do is ensure that the CG is within the limits provided in the envelope. The table method. The table method uses a series of tables provided by the manufacturer to eliminate the multiplication and division that we do in the computation method, but not the addition. A moment table is provided for each of the most common payload areas, such as front seats, rear seats, usable fuel, baggage areas, all of them. The manufacturer has taken various weights and multiplied them by the arm for each of these locations to obtain the number in the table. To find the center of gravity, start with your list of weights as before. Then look up the weight for each item in the appropriate table and read the moment given for it and note it down. Once you are done writing all the weights and the moments, calculate the total weight and then read across between the moment limits table that if your moment is within the limit for the given weight. For example, a particular weight will have a certain limit of moments from a maximum to a minimum moment limit. Your weight and moment should confide within these limits for that weight. If that does not happen, you will have to rearrange the load. The table method uses rounded weights and all of the moments are rounded as well. Approximate arms are used, so it is not as precise as the computation method. But this method eliminates the possibility of arithmetic errors as we need to do a lot of arithmetics in the computation method, which is eliminated here. If you notice that the table method does not give you a CG range in inches from the datum. Instead, it gives you the moment limits for a whole range of total weights. This eliminates the computation of CG as well, which was the final step in the computation method. Now, if you see, the moment figures in the table method are much smaller than the ones we got in the computation method. This is because the manufacturer usually rounds off the numbers to the nearest hundred or thousands depending on the weight. These are called reduction factors because they round it off to the nearest hundred or thousand and then drop the zero to make the calculation easier. But don't worry about it because the moments are also rounded off. So both the weights and the moments are reduced by the same reduction factor. Hence the chance of error is not much. Here, as we said before, the table method is not using accurate numbers since everything is rounded off. but it also reduces the chance of arithmetic problems or arithmetic errors compared to the computation method. This also eliminates the need for calculating CG by giving us the moment limits. The only problem with the table method is that sometimes uncommon weights are not given in the table, and then you will have to interpolate and calculate it using the computation method. The third method is the graphical method. The graphical method is very similar to the table method. The only thing is that all the values from the table are plotted on a graph. So the graph method makes it easier to use intermediate values and increments in between the figures that you got in the table method. You need the graph for the loading and you need the graph for the CG envelope. These are the only two graphs that you need for the weight and balance calculations. The graphs also have a reduction factor just like the table method, but these are much more easier to use, especially for the intermediate values that I said before.